She was doing non-math in math class. I don't like that. It will make me cry. Did you guys get it? 2 halves make a whole. Get it? It's a donut. Okay, no? Bad joke? Okay. All right, with this one, I thought the middle section, well, not this, I thought the top middle section, this one to me was the most interesting and probably the most difficult. Maybe? No? This one was okay. So we don't need to go over any of these. These were fine. There was addition and subtraction, but it was still weird. No? Fine. Okay. Okay, so it made you think outside the triangle a little bit. It started off as a sarcastic laugh that quickly turned into a real laugh with your guys' like reactions. That was a real, even though there's like dad jokes, that was like a teacher joke that was like real good. All right, how did we do with these ones? Did we recognize that was the letter Q? That font was real solid. On my answer key as I made it, I was like, G question mark, Q question mark. I'm not sure, but I know the answer is 7x squared. I don't know what letter it is, but I know what the answer is. All right, do you want me to go over any of the last 3? Okay, now we had gibberish answers yesterday in class, but we figured it out. Yeah, that was good. So we actually are fine on this? We're good? We don't need... We're good. No? Okay. Well then fine. Okay. All right, let me go ahead and hand out the notes for today then. This looks like a worksheet. And I was like, Gina, not to hate on you, ma'am, but this is a boring worksheet, so I'm going to use it as notes instead, and we're not going to do all the problems. We're just going to do enough so that we feel like we can remember how to do this stuff, because we have learned it before. And then once we feel like we remember how to do this stuff, we're going to put this away as notes, and we're going to do punchline practice as worksheets today. Okay, we're going to do 2 days of review practice. Today is going to be like the sit, try all the problems. And then Monday is going to be like an around the room type of activity, some sort of activity. I don't know what it is. I haven't made it yet. Okay. So here is the first type of factoring review, which is greatest common factor. So of those 4 problems, which one would you guys like to start with to get your brains back into it? Start with 3? Okay. So between the 3 numbers, we're going to look at what is the greatest common factor. So what number can you divide out of 14, that you can divide out of 35, that you can divide out of 7? You can divide the 7 out. Okay? And then whenever you have a variable that's in common, you always take out the lowest exponent. Always the lowest. That's what's going to be the GCF. So for all of these, we have m squared is the lowest exponent, so m squared is what we're going to take out. And so since we had 3 terms, that means that in our parentheses, we have to have 3 terms. So 14 divided by 7 is 2. And we have m to the 6th. We took 2 of those m's out. So how many do we have left over? 4. M to the 4th. Okay. 35 divided by 7. 5. We took out 2 m's, that means we have 1 left over. 7 divided by 7, 1. And we took out m squared, so we don't have any m's over that are left to right. So that's what we've got. Easy peasy. Oh, thank you for finishing that. That was nice. It was almost like we rehearsed it, but we did not.
We know you guys were
Yesterday, you should have seen our practice. We could not get it right. I said easy peasy, and she was like, lemon pie. I was like, no, it's lemon squeezy. It's lemon
And then
squeezy.
you were like, oh, super easy.
And then I said easy peasy, and she said blueberry squeezy. And I was like, that's not how it goes. That's not how it goes. That's not how it goes. And we practiced it after berries. Berry fruit. Anyway, after an hour and a half, we finally got it, and today it was smooth. You didn't even know it took us an hour and a half to get there. All right. Let's look at number 2. So between 40 and 64, what number? 8. Mm-hmm. So 4 does divide into both of them, but it's not the biggest number, which tells you that you need to go for something a little bit bigger. All right, between the x to the 8 and the x to the 4, what should we take out? X to the 4. And then between y and y, what should we take out? Y. Between y and y, what should we take out? X4. That was my favorite answer of the day.
X4Y.
X4.
I just heard
I heard a very emphatic Y when I said, or X4 when I said, what should we take out if we have Y and Y? X4! It was very confident. All right, 40 divided by 8. 5. If you have x to the 8th and you've taken out x to the 4th, what's left over? X to the 4th. If you have a y and you've taken out a y, what should you do? No y, stop. All right, so plus 64 divided by 8. You have an x to the 4th, you've taken an x to the 4th. You have a y, you've taken out a y. Nothing. Okay, do you want to see another example? So the number is, there's no GCF with a number, but what about the variables? Yeah, you can work with the AB. Do you guys want to go ahead and try number 4 without me telling you anything? Go ahead and give number 4 a shot. Like, don't shoot it, don't be violent, but like try it. All of a sudden, I hear like pew, 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 pew. Avery, don't make me chuck that book across the room. That's fine. Oh, that's fine. That's fine. I don't like it, but it's fine. Sure. Yes. Yes. When you multiply exponents, you add them. When you divide them, you subtract them. So when I did this one, I was like, x to the 8th is 1, 2, 3, 4, 5, 6, 7, 8. And so I was like, okay, if there's 4 of them in the front, then I need to have the other 4 inside. That's what I was thinking of. So I was basically subtracting them. I was like, if there's 4, that's how I think of it always. Yeah. By the GCF. Yeah. Yeah. Yep. A lot of students are kind of uncomfortable with division, but they're a little bit more comfortable with the idea of subtraction, which is why I say, if you've got 4 in the front, how many are left over? Because most students will pretty comfortably answer that. Whereas when you start saying division, they're like, division, no! I feel triggered. It is division. It is division. Yeah, because it's the opposite, right? Like this, if we write it like this, we're saying we're multiplying these two things together. So we are undoing multiplication, which means we are dividing. We're dividing it out. We're factoring. When you factor something, you are dividing it out. So it's two different ways of thinking of it. hmm All right. So does somebody want to tell me what they came up with for the GCF? Nate, what did you come up with? Okay, and then what did you have? Wait, so what was your first term again? I just didn't hear you. Your first term? Negative 5a. What went here? No, you're right. I just missed. Oh, I see what you're saying. Okay, so you put negative 5a first, then what did you put? Uh-huh. Plus 8. I got you. Okay.
I did that wrong.
No, you're not. Nobody. You're not wrong. You're not wrong. What he did is he factored it. He had the AB, the 3b minus 5a plus 8, and then he said that's not alphabetical. Let me fix it so it's alphabetical. Right? Yeah. Yeah, that's fine. They're both equally. They're both mathematically accurate. A lot of times when people are factoring, they wouldn't switch it in alphabetical order, but that's out of laziness, not mathematical accuracy. So typically, here's a good clarification on what we learned yesterday. The part where you do alphabetical order is for standard form. So this should be in alphabetical order with your exponents from biggest to smallest. When you do the factored form, people are not as nitpicky. Does that make sense? So typically, they would take the GCF out, and then they would just write the order that it came in, and they would not rearrange it. They would just call it good. But if you switched it around and put it in alphabetical order, some people would go, yeah, does that make sense? You doing that? And some people would be like, oh, that throws me off. There's no like should or shouldn't. It's yeah, that's fine if you do, and it's yeah, that's fine if you don't. So it's okay either way. Yeah, that was good. I'm glad we talked about that. That was a good one to talk about. Okay, how do you guys feel about GCF? Good? We're comfortable with that? Okay. So when you are factoring, GCF can always happen. GCF shows up in any problem ever. So it's often, so we have these problems that are like the only type of factoring they have is just a GCF. So there are problems where it literally is the only type of factoring you can do. But then we have these other problems that are called trinomials. And sometimes they have a GCF where they just have an extra variable in each term. And sometimes they have a GCF where they just have a number in each term. And sometimes they have a GCF where they have both. Okay? I would say the most common thing that I see with them is they have an extra number in each term. That's what you see most often. Okay? So when you're factoring these, always look for a GCF. Because it makes the problem easier if you can take that GCF out, because then the numbers are smaller, and smaller numbers are easier to work with. They're more manageable. Okay. Do you guys remember, we talked about this the other day. Anyone remember how we do this? 45 and the 14? That's Pythagorean theorem. Something about multiply and something about add.
Yeah, because I know it's like the parenthesis where you have, it's like parenthesis x, and then like once you do FOIL, it becomes this problem again. But like I forget the correct step.
Say it again.
It's the formula on the paper.
That's not a formula. That's just telling you what it is. Yeah, so you're looking for what multiplies to 45, but adds to 14. Now, yeah, so now I always write my numbers like this. And your teacher last year may not have done this, but I always put this on my answer keys because this is habit for me. Do you have to do it? No. You do not have to do it. I compulsively do this because I always have. Okay, so you're going to see this on all my answer keys because I always do this. Okay, so I'm going to say what multiplies to 45, but adds to 14. You do not have to do this. I do this because I have to see it written down. Okay, this is just how my brain works. Okay, Miss Rice, I am bad at multiplication. That's fine. Here, let's use our calculators. So I'm gonna hit. This is how we clear our calculators. I'm gonna do second plus 712. Second plus 712. That will clear everything that's been done in your calculator. The calculus kids have been using it. The math 3 kids have been using it. All sorts of funky things have happened to your calculator since you probably last picked these up, if you're using one of mine. So if we are not very good at multiplication, if you don't know all your multiplication facts off the top of your head, you can hit y equals, and you can do 45 divided by x. 45 divided by x. The x button is right here. See it right there? Right next to the green button. Okay? So I hit the y equals button right here, and I typed 45 divided by x. And I will tell you as many times as you need me to tell you how to do this. Okay? Okay, so 45 divided by x. Then what I do is I hit second graph. So these are all of my options. These are all of the number pairs that multiply to 45. So what I'm doing is I'm scrolling through them and I'm looking for two numbers that add to positive 14. So I'm not going to scroll up because those are negative pairs. Negative pairs are not going to add to positive 14. Those are bad combinations. So I'm going to scroll down. 1 and 45, that's way too big. I'm going to skip the decimal answers because I'm not looking for a decimal answer, okay? So I got 3 and 15. That's closer than 1 and 45, so I'm on the right track. I'm going to keep going. 5 and 9, does that work? Yes. Okay, so 5 and 9 answer. So I can say x plus 5, x plus 9. Multiplication, this is multiplication, one thing times another thing. It has what we call the commutative property, which means you can switch the order and it still works. So you could also say x plus 9, x plus 5. Those answers are considered equivalent. Okay, so it does not matter what order you put them in, you have given me the same answer. Okay, both of those answers are fine. You do not have to write both down. You give me one or the other, and I will say we have the same answer. Does that make sense? Okay, cool. So let's try between 5 and 10. What's another number you would like to try? Between 5 and 10, what's another number we should try? Let's try number 6. Okay, so we're going to look for two numbers that multiply to 26 but add to negative 15. Okay, so I'm going to go back to my y equals. I'm going to do positive 26 divided by x, and I'm going to hit second graph. Now this time we're adding up to a negative number, so I'm going to go in the negative direction. Negative 1 and negative 26 adds to negative 27, so that's a little bit too negative. Negative 2 and negative 13, that definitely works. Negative 2, negative 13. W minus 2, W minus 13. So this is how we can use a calculator to help us if our multiplication skills are not as strong. Now, if you're on your way through the honors track and you want to do honors math 3 and you want to do honors pre-calc and you eventually want to get up to AP calculus, they are going to start taking your calculator away from you, which means that you've got to get to the point where your multiplication facts are pretty strong. So if you are using a multiplication, if you're using this for problems like, oh, I have to find what multiplies to 576, that's pretty good. But if you're having a hard time finding what multiplies to 48, or finding what multiplies to 50, or finding what multiplies to 24, then you probably need to work on your multiplication tables. Does that make sense? Okay, so even if I've got 3-digit numbers, I'm probably going to get out a calculator to do some of those just because I'm lazy. I'm going to be honest with you, I'm lazy. But if I have some of those 2-digit numbers that aren't super big, I'm probably going to do those in my head. Make sense? Okay. All right, let's see if we can do number 7 without a calculator, okay? This one's going to be kind of tricky because we're multiplying to a negative number. We're multiplying to negative 48. We're adding to positive 2. Don't say it out loud. But to multiply to a negative number, that means you have to have one positive number and one negative number. So don't say it out loud, but think about what two numbers might make that happen. One positive number and one negative number that multiply to a negative 48, but they add to a positive 2. Don't say it out loud, but think about how you could make that happen. One positive number, one negative number, multiplies to negative 48, adds to a positive 2. Right. Say it again. Yeah, once you've written down a number, go ahead and check it with your calculator, see if it works. Multiplies to negative 48, adds to 2. So multiplies to C, adds to B. Multiplies to C, adds to B. Yes? 6 times 8. Negative 6. So we have C minus 6, C plus 8. Okay. Let's try number 8. Multiplies to negative 72, so we're multiplying to a negative again. So we're going to have one positive, one negative. What are we adding to? Negative 1, good. So multiplies to negative 72, adds to negative 1, don't say it. If you need to type this one in your calculator, that's fine. You're going to type negative 72 divided by x if you need to do this one in your calculator. So negative 72 divided by x. The ones like this often throw students off. Multiplies to negative 72, adds to negative 1. Don't say it out loud. Don't say it out loud. One positive number, one negative number. When you think you've got it, feel free to check it on your calculator. One positive number, one negative number, multiplies to a negative 72, adds to a negative 1. All right, anyone want to share what their numbers were? Jack? Yes. Negative 9, positive 8. So we have n minus 9, n plus 8. N minus 9, n plus 8. Perfect. Okay, let's jump down to number 11 or 12. Which one would you guys rather do, 11 or 12? 11? 11. Okay. So what's happening with number 11? Why is it different from the others? It has a number. Okay. What do you notice about that number? Yes, Peter. It can be reduced. So if we look at the number 2, what do we notice about the other numbers? They're all divisible by 2. So this problem has a GCF. GCF. We got to take that GCF out before we do the rest of the problem. So we cannot start this problem saying, oh, what multiplies to negative 40 and adds to negative 16. If we do that, we'll get the answer wrong. Yes? Don't answer it yet. Everyone else wants a chance to answer it. If you feel antsy, you can go ahead and do number 12. Did you do number 10? Okay. Okay, so Jack, here's your assignment. I need you to draw Nate with your opposite hand. Okay. All right, so we got 2, we got k squared, then what should we put next? 8k and then what should we put? Minus 20, okay. So we are looking for 2 things that multiply to negative 20 and add to negative 8. And we're going to make sure that when we put our final answer, we're going to have a 2 in the front of it. So we can't just divide by 2 and ditch that 2. That 2 has to be in our answer, but it's not going to be part of what we're looking for. So looking for 2 numbers that multiply to negative 20, add to negative 8. Since we're multiplying to a negative 20, we're going to have 1 positive number, 1 negative number. Don't say it quite yet, but I'm going to come to you, okay? So take a moment, 2 numbers, 1 positive, 1 negative, multiplies to negative 20, adds to negative 8. Your drawing can't be done yet, man. It was your opposite hand.
I know. I am an artist.
You want to see accuracy? That doesn't look anything like that.
That looks exactly like me. She agrees. So does Sophie. Sophie does too. And she agrees that that's me. That is me.
Is it extra credit?
I'll tell you in a second what we're doing. All right. All right, Sophie, what did you get?
Well, I got 2x minus and x plus 2.
Wait, you got what numbers did you get?
X minus 10, x plus 2.
X, or K. K minus 10. K minus 10. And K, what was the other one?
Plus 2.
Perfect. So the 2 numbers are negative 10 and positive 2. And we get the 2 in the front. K minus 10, K plus 2. Okay, here's what we're going to work on. We're not going to keep doing the notes. We're going to take a pause, take a little break, and work on just the sheets that have to do with the notes we just did. So the first sheet is just GCF, okay? This first page is just GCF, and the problems get a little crazy. Like, they start off like, GCF, GCF. So here's how the assignment works. You are going to match up a number with a letter. The GCF comes from this column. The leftover parentheses come from this column. Does that make sense? So if we do problem A for the first set, what's the GCF between x squared minus 6x? X, okay? And then what do you have left over? X minus 6. Okay? So that means that we're using 16 as the GCF. We're using O as the leftovers. So in spot 16, you're putting an O. Oh. Okay. All right. Let's jump down to set 4, problem C. Oh my. Oh my. Oh my. No, just kidding. Let's do problem D. That one looks a lot more difficult. Okay. Okay. Between 144, 27, and 9. 9. Okay, let's try it. 144. Does 144 divide by 9? Yeah. Oh, thank goodness. Thank goodness they gave us that 9. Okay, 9. X to the 8th, x to the 4th, x to the 2nd. Okay. Y squared, y, no y. Okay, no y. All right. 144 divided by 9. 16. Okay, we have x to the 8th and we took out 2 of them. X to the 6th. We have y squared and we didn't take out any y's. So we still have a y squared. Okay. 27 divided by 9. 3. We have x to the 4th and we took out 2 of them. Okay. We have a y and we didn't take out any y's, so we still have a y. 9 divided by 9 is 1. And we had an x squared and we took it out. Okay. So what number are we using? 5. So for 5, what letter are we using? N. So for 5, we're putting an N. Ta-da! Okay. So we see how this worksheet goes. So some of these are like, dee, just a little GCF is cute. And then some of these are like, whoa, GCF, oh my goodness. Okay, turn the page. So on this page, there are some problems that I found to be unnecessarily ridiculous, and so I'm going to tell you the answers. Yeah, some of them I think are going to be extra credit, and some of them, like I said, I think are unnecessarily ridiculous, and so you're not going to do the whole one. So it says, cross out the letter pair next to the answers, and then the leftover letters that you don't cross out to write the uppercase letter in the box containing the lowercase letter. So when you find the answer, you're going to cross it out, and then you're not going to use it. Does that make sense? Okay, well, I'm going to tell you which ones to cross out, okay? So this section over here, you are not doing this section. See this, how it has problems are not common. Even in calculus, they're not very common, and so we're not going to do them. So the first one you're going to cross out is this one. Nope, I'm just going to tell you what to cross out. Cross out this one. Well, because I still want you guys to be able to get the punchline. It'd be so frustrating to do this and not be able to do the punchline. So the answers that are going to contribute to your punchline are this one, and this one are going to contribute to your punchline. Yeah, so write the uppercase letter in the box containing the lowercase letter. So the lowercase letter T gets the letter D. The lowercase letter O gets the letter T. Well, let's say this is just, they're also teaching you how to follow instructions and make sense of directions. Okay, I'm telling the 3 next that you don't have to do, but we're still going to do the punchline. The 3 next you don't have to do is this one, this one, and this one. Okay, so these are the ones that are giving you answers. So lowercase r gives you an N.
Have a lowercase o.
That's interesting.
Who did it from? It's Marcy. At math. Well, this math does
Come on,
not
Marcy,
work.
math works. What the heck is Marcy?
Marcy. 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 Oh no.
Oh no, it seems like we can't do this worksheet. No, maybe we can skip to the next page.
Yeah.
Maybe we get it for extra credit, even though we can't.
Hold on, let me think.
In a participation.
Seth, I need you to Seth, I need you to sit outside.
Why?
Because I said so. I'll look at that one. So I've done all the problems, I just haven't checked the punchline. I will work on that in a second. Okay. So let's go ahead. Ooh, let me not show you the answers. Let's go ahead and try a couple of these and just make sure that we're kind of understanding how it's working. So let's go ahead and do the first set. And then let's plug in some of these answers and make sure that they kind of work. Okay. So the first one, we're looking for two numbers that multiply to 12. And add to 7. Okay, but don't shut them out. Let people do their work. Two numbers that multiply to 14 and add to -9. Two numbers that multiply to -12 and add to 4. And while you guys work on that, I'm just going to double check and see my math on the other ones and see if maybe I made a mistake. Oh, I had you guys cross out the wrong one, I just realized. I missed my sign. So it was this one is the one we were supposed to cross out. This one was the one we were supposed to cross out. This one is the one we were supposed to cross out. We were supposed to circle this one. I missed that I had a plus here, not a minus. It's J is supposed to be I. So sorry. J is supposed to be I. Yeah, and the whole bunch is there. J is supposed to be I. I just couldn't read my own handwriting. J is supposed to be I. And this is not supposed to be crossed out. And this is not supposed to be circled. That was my bad. Sorry. Yeah, and so O is actually C. There we go. Okay. So it appears that it really does work. So right now, you are not doing the whole packet. What I did is I pulled worksheets that I liked that I thought were good, and then I didn't narrow it down. I just pulled them all. And we are for sure doing the first page front and back. What probably will happen is I'll either have us do this over the course of 2 days, or I'll make some of them extra credit, is what's probably going to happen, okay? But there's some pages where I don't like part of the page, and so I will say, hey, we're not going to do this part of the page, but I'm going to tell you the answer so you can still do your punchline. Does that make sense? So you're doing the whole part of the front of the page because I thought those were some really good GCF questions, and then you guys are going to do 1 through 21 for sure because these are good questions for that. And that's what we're going to start with, and then we're just going to see how far we get today. We might end up doing 3 days of factoring just to make sure that I don't overload you. Okay? So, yes, there are 6 pages. Are we going to do it all at once? Am I going to make you do factoring all weekend? No. Okay? I just wanted to make sure that we did have plenty of practice to do. All right.